Every time we have a test, she have diarrhea. Okay? At first, when she called me on the day and said, Dr. Wu, I have intense diarrhea, I cannot go take my test, okay? I give her the benefit of that, right? People do that. Okay? And I asked her, well, go to the school clinic and make sure that clear from that and take something for that. She had diarrhea for the last, when she started studying for the test. Yeah, right. Well, give her benefit of that. And then, the second time, the same day, we have the test, you call up, Dr. Wu, I have diarrhea. Again. Okay, so, yeah, I'm kidding, and I'm in the clinic right now. And I talked to the doctor and said, yes, she's dehydrating and she has diarrhea. I have to give medication, she's in no shape to take the test. Okay? And then the third one, guess what happened? I have diarrhea. I almost said that I have a little thing, the portable thing back in the room. You can have diarrhea and take my test right there. Right? Because now I don't think it's funny anymore. Does it make sense? Well, you know the story, right? I'm just really skeptical. But the evidence came out, and the evidence came from the internet right there. In her case, she just scared. And you know that. Why you scared of my test? I don't know. Every time I take a test, she's scared. And when she's scared, her entire system activate. It causes instability of her gut if she has the diarrhea. However, when she walked in the class and say, we may have the test today, and she will study, she's doing fine. But when I say, that test right there, today you come and take the test, she studied for the test, she had diarrhea. Okay? I think eventually she learned one of that she goes to psychology and work it out. And that is the clue. Enteric. Alright? And these are the ones that we need to talk about a little bit. Okay. Based on the chemical composition differences, how do you classify the neurotransmitter? 5, right? Acetylcholine, biogenic amine, amino acid, polypeptide, and the novel messenger. Are you with me? But based on the function, very simple. If a neurotransmitter induces the EPSP, we call that an excitatory neurotransmitter. Does that make sense? Right? If something makes me happy, I call him, oh, he's a happy guy. Duh. In contrast, the neurotransmitter that induce IPSP, okay, we call them the inhibitory neurotransmitter. Is it easy? Right? Much easier than the chemical, right? Inhibitory and excitatory. And we learned that ATP, unlike the other amino acid only found in the CNS, ATP can be found in both CNS and PNS. Not only that, the ATP can produce either way. It can produce excitatory and inhibitory as well. And you look at me and say, how can that be? How can a single chemical that produces the opposite effect? That cannot be. The answer is of course not. Right? Make sure I identify this. The ATP may be in your gut. It produces IPSP. In your brain, it produces EPSP. And you look at me in different places, but it's the same chemical. So why is that? Why is that the neurotransmitter identical in every way, produce exactly the opposite? And the answer that you learn much more detail in AP2. The answer is it activates the different receptor. It's not the chemical that different, it's different receptor. Right? Okay? I can show you the evidence is this. How many times you guys come into my office, okay, and I look at you and say, what do you want? If you don't know me, right, and you are somebody else, you take that an offense. I come and ask for help and you look at me, what do you want? So the reaction of the students who are not in my class will say that guy is mean. Are you with me? But if you are in my class coming in, and you see before, Elaine come and say, what do you want, Elaine? Oh, I just want to see my test. I don't care what you said. Does it make sense? It's the same me, in the same sentences, but the reaction is different because I talk to different people. The same thing in your body. Different receptors react differently. Is that cool? Okay? And that's all I want you guys to know. Right now, I don't think it's a good thing to mention anything in detail. However, we will find out that among other things, one of the things we learned at ATP also mediate your pain sensation as well. So right now, you know, 2 neuron transmitters that mediate your pain, substance P and ATP. Okay, if you have time, go to the library or something and read a journal. And that journal title is Pain. P-A-I-N. We have a journal every month talk about pain. What does that tell you? We don't know deadly what, how pain process. Okay, that's why they have a whole journal talk about I find thing, new thing. And you will see, open it up, that many articles, a lot of things talk about ATP. Nitric oxide. Okay, the nitric oxide, we know that they involve in learning and memory. So when you learn something that appears really quick and disappears. Beyond that, I don't want you to go into detail. Last but not least, carbon monoxide, as we mentioned, that can function as a neurotransmitter, but what we know about them are very limited. So I don't want you guys to learn it activate the cycle of GNC, all that. Just know this, for the nitric oxide and carbon monoxide, just know that they are not very common neurotransmitter. They're both gases. However, we learned that they also function as a neurotransmitter. You should know that nitric oxide also involves learning and memory as well, where the carbon monoxide, they still don't know. Based on the function, as we mentioned, right, if the neurotransmitter produce EPSP, they classify as a excitatory. If they produce IPSP, they are classified as inhibitory. Okay? Glutamate. Is that name ring a bell? Glutamate is an amino acid. It is the most abundant neurotransmitter in your brain. It also knows, based on the chemical, glutamate classified as amino acid. Based on the function, they classify as excitatory neurotransmitter. Where the other neurotransmitter, remember GABA and glycine? Okay, GABA and glycine are the two amino acids that we learned it only produce IPSP, and they found in your CNS. We talked about briefly, remember, if people who have grand mal seizure, okay, where your muscle contracts so fast you go to seizure, okay, to prevent them, they do take some medication. And those medication actually a GABA synthetic form. Why taking GABA would help? Well, what did I tell you about why do you have seizure? The brain sends an electrical storm down your spinal cord, and your motor neuron react by activate the muscle like crazy. Does that make sense? So is any way that you prevent those neurons from sending a signal, you will reduce the incidence of having seizure. What's the better go? Send the IPSP to those neurons. And that's why some medication that help to release a seizure are the synthetic form of GABA. Okay? Some neurotransmitter can be both excitatory and inhibitory. One you will learn obviously, ATP, right? Well, another one you may not know yet. Acetylcholine again. What is that? Acetylcholine in the NMJ, what does it produce? That make the muscle contract. Remember they open the ligand, get a sodium channel, sodium enter, the muscle generate action potential? It's EPSP, right? So at the NMJ, it produces excitatory. But in the heart, what happened when Louis scooped the juice from the first heart and put that juice on the second heart? What happened to the heart rate? It slowed down. And we learned that that's acetylcholine, but in this case, it actually decreased the muscle contraction. You guys see that? Okay? How many more slides do I have? Huh? 10 more? 7 more. Okay. Which means that please print out chapter 12. Okay, 11, yeah, chapter 12. At least print the first, I think we have 120 slides on that chapter. Print out the first 40 slides for me. Okay, this is fun. This is the one that you should learn from the last week, right? The